simulation program for protection of P2G and G2V system. Shown here is the circuit proposed for the house breaker and the electric vehicle breaker with overcurrent relays. The overcurrent relays for the EV is checked to see if it works in both cases where EV is acting as a load and as a generator. The differential relay wraps around the main breaker of the house and the EV breaker. The table here shown describes the tripping schedule for the breakers of the house and the electric vehicle while it's serving as a load and as a generation. This will be demonstrated with a MATLAB Simulink program. The first scenario is the fault on the EV or electric vehicle circuit when EV is acting as a load. The overcurrent relay, which is displayed here, uses a pickup current and a time delay. The results of the system here will show, the first one will show the overcurrent passing through the electric vehicle breaker. The second plot shows the breaker position of the electric vehicle, which trips at a time of approximately 0.05 seconds. The house breaker will remain closed throughout the system, and this is what you will expect to see. In this scenario, we will see a fault applied on the electric vehicle circuit while the electric vehicle is acting as a generation. Same here, the electric vehicle breaker will trip on the second plot and the house breaker will remain closed throughout. So far we have simulated fault location B on the EV while the EV is acting as a load and EV is acting as a generation, and we have demonstrated that the house load will not trip for these faults, but that the EV breaker will trip for the two conditions. Next up we will demonstrate fault A, which is fault on the house, and see how the EV and the house breaker will trip. Here the fault is located on the house circuit, and we will see that the EV, which is acting as a load, does not trip for this fault because it's outside the zones of protection. As you can see, the breaker position for the house is switched off while the breaker position of the EV remains the same, which means the EV remains closed. Now the last scenario for overcurrent relay is when the fault is on the house circuit while the electric vehicle is acting as a generation. This is a special condition because the electric vehicle breaker will trip before the house breaker, because the generator could be a source of fault, or it could feed more fault into the system. So we'll see that the EV generation will trip first before the house, and this is demonstrated in this diagram. Fault current again on the top, the breaker position of the electric vehicle, and the house breaker. Now the house breaker, if we have an extension up to maybe 1 second, we will see that it will trip right after the electric vehicle breaker trips, and this is shown on the MATLAB on the CAPE program on the paper. Over here we have the differential relay. The differential relay only takes to see if the two currents add up to a zero current. As you can see here, the second plot shows the breaker position of both the EV and the house breaker, which will trip for a differential current. Now the differential current, the pickup will be, or the tolerance will be changing when there is electric vehicle loading. Here is a differential relay with the EV as a generation. As you can see here, because the fault has a high oscillation, we will have to use a tighter window, which I have explained on the paper. Next up is the reclosing scheme, which is shown in this table. This table is written in a MATLAB code, which looks something like this, and when this MATLAB code is run, we can demonstrate that it will give us the same result as the table given.